So hi everyone, hello, a very good evening and a very warm welcome. I hope everyone is doing great, fit and safe most of all during these very difficult times of COVID. Thank you so much everyone for joining us for this very exciting discussion which waits ahead of us. To begin with, I'm your host and my name is Sweetie Lasani. I head the learning and development team at Maven Silicon. And speaking about Maven Silicon, the center of excellence when it comes to the VLSI training, we've been in the skilling space for more than 12 years now, deploying 500 plus VLSI engineers and being partners with 250 plus semiconductor companies. I must say that Maven Silicon is definitely a key holder in the semiconductor industry's value chain. And one of our recent developments at Maven Silicon is our partnership with RISC-V International, which is definitely the talk of the town. RISC-V is a free and open ISA, which is enabling a new era of processor innovation. The RISC-V ISA delivers a new level of free, extensible software and hardware freedom on architecture, which is actually paving the way for the next 50 years of computing design and innovation, which I would say is marvelous. And then now, without any further ado, I'm sure that all of us are really waiting for that moment. So without further ado, let me quickly introduce to our very special guest and the panel for today's discussion. And my first guest today, ladies and gentlemen, is Ms. Calista Redmond, who is the CEO and CEO of RISC-V International. And Calista is definitely on a mission to expand and engage RISC-V International all across, I'm sure, within and outside RISC-V International. So hi, Calista, welcome on board.
Thank you so much for having me.
Thank you, Calista. Thank you so much for joining us. How are you doing today?
I'm doing great. I'm doing great. You know, it's a profound moment in history, and I'm excited to be part of this. You know, just as a wee bit of background, if you like, you know, I joined RISC-V about 3 years ago already. These have been the fastest 3 years of my life in terms of the acceleration that has gone on in this community. Previous to this, I spent about 12 and a half years at IBM working on all things hardware, all across each of their pieces of the portfolio, from chips to systems. I worked on everything from, you know, back in the day when we had x86 all the way through to mainframe and all things in between. So joining RISC-V and the momentum of this community has been profound. And it's so exciting to continue welcoming folks into this journey, regardless of their starting point. And so it's really important for us to engage deeply in India and with Maven Silicon to continue fostering that opportunity.
Absolutely, yes. And thank you so much again, Calista, for taking out time in your really busy schedule. And yeah, moving to the next person and the next in line, our very own the founder and the CEO of Maven Silicon. Ladies and gentlemen, again, I have here with me is Mr. Sivakumar P R. Shiva is the founder and the CEO of Maven Silicon, and he's also the founder and the CEO of ASIC Design Technologies. For me, Shiva is the man behind Maven Silicon, right? The strategy, business, technology, courses, curriculums, the evolution basically that Maven Silicon actually has seen in the last 2 years, specifically in the online learning space, and you know, moving from a very traditional brick and mortar business to really revolutionizing the whole online VLSI learning. I think kudos to Shiva for that. And yeah, let's have you, Shiva. Welcome on board again.
Thanks, Sweetie. Nice connecting with you, Calista.
Right. So thank you so much again, both of you, for taking out time and doing this really special chat session with us. So let me quickly introduce the topic. The topic of the discussion is RISC-V, the open era of computing. So the format that we have is very simple. It's going to be a simple Q&A, and I have a couple of questions that I will be asking you both one by one. And the idea is that that's how we develop a very deeper understanding on the topic, and we create a lot of sensitization and awareness about RISC-V for the rest of the world, right? So are we ready?
Let's do it.
Right. Let's do it. Yeah. So, all right. So, Calista, I think my first question is for you, and I would really like to understand, Calista, from you, the what and why of RISC-V. An introduction to RISC-V for all our audience, please.
Well, let's go way back in time. No, I'm just kidding. We're going to go a little back in time, but not too far. So, in the 1980s, there was this massive processor competition, right? Everyone had a different processor, and they were competing to be really the heart and soul of computing. And at the end of the day, amongst all of these different experiments, Intel really kind of like barreled out in front with, volume, end-to-end foundry design, everything. And they were able to get to scale because they were investing millions of dollars, hundreds and thousands of engineers. So much went into that. And you could have a processor, a computer, a server that had a constant supply of energy plugged into the wall. Okay, 20 years later, we started to see things that were more portable. Cell phones, laptops, ThinkPads, small devices that didn't connect to cell phone towers at all. And there was another competition. It was another wave of competition in microprocessors. And, ARM really came out in front. They really had a model that was disruptive at that time. We are now at the next point in history, the next inflection point. Because along the way, along that hardware journey, we discovered something. We discovered that collaboration in software could help the entire industry form a foundation upon which they could still compete. So along came Linux. IBM planted a $1 billion flag in the industry and said, we are all in. We are going for open source as the building block, the foundational building block for many of our things. And now they had their own software, but there was this sort of like culture that said, let's all share things so that we can build together and collaborate better. So that moment now is here in hardware. At the same time that there's an explosion in customized processors. So custom processors have taken off. So there's opportunity, there's flexibility, and folks want to accelerate that development roadmap. They don't want to wait for scale. They don't want to own their own foundries. They want to participate as a stakeholder in a community and not be the entire community themselves. So the two reasons really that RISC-V is now catapulting forward as the most prolific open ISA that this microprocessor industry has ever seen, like more design houses on RISC-V than any other architecture in history, is two reasons. Number one, the disruptive technology. The approach of the technology is actually modular. You have a very small base set of instructions, 47 base instructions in the ISA, and then you can pick and choose from a menu what you add on to that to build your implementation. That's a lot different than the incremental approach of other ISAs that start with 1,500 base instructions. I don't know anyone that can wrap their head around 1,500 instructions. I don't think there is anyone that knows all of that in depth. So those legacy ISAs have built on for years and decades. RISC-V has taken a modular approach. So that technical advantage, along with it being fully open, and you have design flexibility to take that in any direction you choose. You are not constrained, and now we get into the business reasons. You're not constrained by license. You're not constrained by agreements with vendors. You're not constrained at all. It can take 2 to 3 years just to negotiate a license. You don't have to worry about that. Anyone can take RISC-V and go in any direction they want. So with that design flexibility means you have unconstrained opportunity. You really can build in any direction you wish. If you want to build servers, if you want to build earbuds, if you want to build an HPC system, if you want to build cloud, if you want to build an automotive, you can take that same base ISA and combine it with other instructions to build your implementation. That means that you have unlimited development partners, folks that help you, put together a product to go to market, collaborate on the development and what goes into that design. You have unconstrained supply chain, where you can go to get the design elements, the IP, the testing, the verification, all kinds of parts of that stakeholder community. You can go wherever you like. That opens up where you can take your product. So unconstrained markets. If you want to go into different geographies, different industries, you are welcome to expand that opportunity. Remember, this is all coming at a point in history where the opportunity is absolutely exploding. We are now seeing predictions for 50 billion connected and IoT devices by 2030. That's just around the corner. Every time one of these predictions come out, by the way, they say, oh, I'm sorry, I was wrong. The market is actually growing faster than I thought. So every single chart that I've seen from the analysts just shows this explosion, this skyrocketing opportunity. That means that investors are keen to get engaged, development teams are keen to get engaged, and everyone is saying, you know what? This is kind of the Linux of hardware. Intel's even seen that. Just this year, a month or two ago, they planted the billion-dollar flag and said, you know what? We're all in on RISC-V. Let's help build that ecosystem. So that's why it's so important. And I did warn you, I could talk for hours about how exciting this space is, but let me hand it back to you.
Great, great. Thank you, Calista. I mean, I don't really belong to the background, but all of this was so comprehensive, and I'm sure the numbers were really mind-boggling. So thank you so much for all the details again. And I think I'll pass on the next question to Shiva. So what is RISC-V for us as Maven Silicon? What were our reasons of collaboration with RISC-V?
Yeah, Calista nicely explained why RISC-V is becoming popular and what is going to happen in the future. To summarize, yes, it's free. So we don't really need to live with license restrictions, royalty free. Of course, in the world, nothing comes for free. When it comes to realizing the device, whether it's going to be IP or subsystem or SoC, we need to invest money, time, and that's how things are going to happen. But the most important thing is freedom. It's open ISA, so engineers like me, we love to play with it. We want to customize the ISA as we prefer, and that's also highly needed for the current scenario. You just look at this. Monolithic semiconductor scaling is failing. So it's almost reaching a saturation point. So the big question is, how can we improve the performance of any chip? The possible solution could be like, we can think of packing more and more components. The components could be processors. But how much we can pack the general purpose CPUs? That's where we are looking at using open ISA, because we can think of creating specialized processors. Rather than choosing general purpose CPU, we can also look at the option of using specialized processors or customized processors for artificial intelligence. The best example is Esperanto. I have gone through some of the updates. I have been watching Calista's talk, and she mentioned about all these great customers. Esperanto is one of the big customers. They have designed SoC called ET SoC. They also call it like different flavors, Maxion, Minion, something like that. I need to still understand more, but they pack more than 1,000 RISC-V cores, and that demands more than 20 billion transistors. You just think about the complexity, right? And that's meant for AI application. And that's what really needed at present. So we really need open ISA. But why RISC-V is something important for Maven Silicon? As a founder, why I chose to work with RISC-V International, or why I introduced a RISC-V processor design as part of our curriculum. You know, a lot of engineers come to Maven Silicon because they want to grow as chip designer. So my responsibility is teaching them the concepts, all kinds of concepts, VLSI concepts. And then I love to see everyone as great chip designers. But before choosing any engineer, I would like to ask them questions because I want to really know whether VLSI is their cup of coffee. The important question is, you know, in India, the scenario is different. Engineers come to Maven Silicon because they want job at some point of time. But it's not going to be good for them. It's not going to be good for Maven Silicon. Let's not go behind job, how to get job. Rather, let's look at why VLSI is something important for them and how I chose VLSI. This is the kind of question I always ask any engineer because I want to find out whether VLSI is their cup of coffee. So I asked them one simple question. What is the difference between laptop and smartphone? Sometimes they think so much, but what I really want to hear from them, if they say, generally we use CISC processor, complex instruction set computer for laptop, and we use RISC for smartphone. If they have got that kind of understanding, that might excite me. Wow, he's my boy. I love to work with him because he has got the understanding, the difference between CISC and RISC. Of course, nowadays we use even RISC also, especially RISC-V for everything. Look at Esperanto's chip. It's kind of supercomputer, right? So we don't really need CISC. CISC might go off. So I want every engineer to explore processor, and RISC-V is the best case study. If someone wants to understand logic design, how basically we create the IP or subsystem, how they can approach creating the architecture. Of course, they need to understand digital electronics, right? So RISC-V is a case study. That's how we introduced RISC-V as part of our curriculum. Also, they need to understand big things. If you look at our course, it starts off with the foundation course. As part of our foundation course, we take them through SoC development process. We show them what is there inside smartphone, chips like A14, and how we build such SoCs. But to understand anything like SoC or subsystem, they need to understand what is processor. That is the right way of approaching VLSI, very large scale integration, and how we use VLSI to create complex chips or SoCs. Why this is something important, I just want to take a few more minutes. If I look at VLSI training, it has always been about teaching languages and methodologies, kind of bits and pieces. That is how it has always been. Even in my career, right, I worked on different point tools like simulators, different kinds of verification tools, different kinds of languages. But I didn't have complete idea like how any system would look like. I didn't have any idea about processor. That's what I really wanted to redefine. So in India, what happens is engineers learn these languages, could be Verilog or VHDL or System Verilog, and then they want to add all the keywords in their CV or resume. Then they look at like how fast I'm going to get my job. That is wrong. You understand like how we create systems. So what is laptop? What is there inside? Maybe do you understand anything about BIOS? And when it comes to smartphone, how we create smartphone, why we prefer SoCs, that kind of understanding is really required. That's why we included RISC-V processor as part of our curriculum. So today I'm so happy. All the engineers, they go through processor. So whoever comes to Maven Silicon, they have to learn RISC-V processor. That's how the course starts. And that's the good news I would like to share with Calista. All right.
I love that. I love that everyone learns RISC processor. It was invented in the 80s. So that means that it's such a solid foundation to build a career on. and to expand beyond smartphones. You're absolutely right, Siva.
Thank you.
Great. Thank you so much, Shiva. I'm sure that whatever you said answers to a lot of questions that I'm sure the folks might have around that, why Maven Silicon and RISC-V. So thank you so much for this beautiful explanation. Calista, quickly coming over to you with my next question, that what is happening in RISC-V currently? If you'd like to share some stories about developments that are happening currently, that'll be really great.
So the very quick answer is I only know just a corner of what's going on in RISC-V because there's so much going on that I cannot keep up with it all, nor do I even know about it all until it hits the news. And the news is hitting every day. I hope if you haven't kind of tuned in to what's going on in RISC-V, I hope that you will. Let's just go back for a second to the explosion that we're seeing in the market. So, the predictions are that the semiconductor IP market will go from $5.2 billion in 2020 to $8.6 billion by 2025. So there's a lot of room right there for RISC-V. These are brand new workloads, and that's what we're seeing. And we are on course for the predictions that RISC-V will consume 28% of that market in IoT, 12% in industrial, 10% in automotive. These are huge double-digit fractions and percentages of an exploding market. And, we don't actually issue licenses. We don't negotiate contracts. We don't measure royalties. So that's where we don't even know everything that's going on. So here's a mistake that I made. This is, Calista fell down on her information. In December, we had our RISC-V Summit. And we did a quick calculation of how many RISC-V cores do we think were in the market in 2021. And I stood up on stage and I said, what, we did a quick count of what we think is going on. We think there are 2 billion RISC-V cores in the market in 2021. And Deloitte says, gosh, RISC-V is on fire and the RISC-V market is going to double in 2022. So I'm really excited. I'm in 2022, we're going to have 4 billion RISC-V cores. And Deloitte said, and they're going to double again in 2023. And I said, oh man, we're going to go from 2 to 4 to 8 billion cores in market by 2023. And I stood up and I was really confident about this. And then I was wrong. Because then in March, Andy said, well, actually in January, Andy said, you know what, we were wrong. We thought we did this, but actually we went back and counted. We did, just Andy's did 3 billion cores in 2021. And then in March, they said, oh, we were wrong. We actually shipped 10 billion already. So we're shooting through all of these predictions, and that's just one company. That's just Andy's. NVIDIA has been shipping RISC-V cores with all of their products. Google has RISC-V cores. Facebook is using them in Oculus. You look at our roster, Intel has their own microprocessors already. Things are really taking off. From startups to multinationals. You think about who's getting involved in RISC-V. More startups than any other processor. More small companies, and we have hundreds of small companies that have invested in RISC-V as, this is our business. We're not even going to start with some of these other architectures. We are going with RISC-V from the beginning. In fact, we have a venture capitalist that has come into RISC-V International at a premier level because they are only investing in RISC-V companies. They have $1 billion fund only on RISC-V companies. So if any of you are thinking about starting your own company alongside Siva and alongside me, there are many opportunities here. I have a call later today with another venture capitalist only investing in RISC-V companies in another part of the world. And I see this time and again. And in fact, you know, we are really going now the full spectrum from Alibaba, who has declared a RISC-V strategy across an entire line of their portfolio that is open sourcing microprocessors for cloud and edge servers, to companies like Ventana and Rivos, who have come in as, you know, small startups, have joined our board of directors and have invested fully in RISC-V, to collaborations between universities. We have RIOS, a lab that is a combination of Berkeley and Tsinghua University. They have invested in RISC-V. To governments like the European Union and the European Commission and their EPI initiative, to India with the Shakti processor that has shifted onto RISC-V. These are fantastic validation points and sources of strength for countries, for companies, for investors, for multinationals, as well as entrepreneurs to start your journey with RISC-V. It doesn't need to be only RISC-V. You can do a both-end approach. That's what's making the skills that folks like Maven Silicon are helping infuse in the industry to jumpstart your career, to make your career portable. Be portable across architectures. Make your workloads portable across architectures. You will be invaluable to your investors, your board of directors, your employers, everywhere you turn in building your career. So we are really seeing it, the full spectrum of compute, from data centers and cloud and HPC to telecom. You know, we have Huawei on our board. We have others that are engaged in 5G. Andes is working closely with SK Telecom. Google's Pixel 6 Titan M2 has hit the road to success as well. We're seeing it in automotive. So RISC-V is being validated to the very high standards of safety and security. You know, we have things like Mobileye that are working on RISC-V. We have Imagination that is deeply involved with GPU linked together with RISC-V cores, meeting the safety critical standard certification. So automotive is a huge domain. All of these are possible because you no longer need to own the full stakeholder spectrum, from design to foundry to engineers to architectures to IP and everything in between. You see things otherwise in automotive like Europe's GA Next program that is helping to design power converters to ensure that you can continuously charge vehicles and that that's done efficiently. We have companies like Huami that have been engaged in RISC-V on consumer and IoT devices. Whether it's consumer or industrial, those IoT devices and acceleration and AI are the differentiators, the opportunity that is compelling companies forward. So take, for example, a large multinational. They want to compete in data centers. They want to compete in cloud. They're not going to do it just by scaling down or having more servers. They need to differentiate. They need a competitive edge. So they're adding on to their existing investments with AI or accelerated workloads. Adding on to an existing multinational investment is where RISC-V comes into play. You won't get very far in your career if you say, hey, let's rip out all that investment we've done in some other architecture and go to RISC-V. And that's kind of a career-ending move. If you say, we can compete effectively by adding this RISC-V differentiator to our existing investments, that's the path forward. And then let's talk future generations and shifting to RISC-V. And that's really what we're seeing, whether it's AI, you know, the types of things that Siva is talking about with Esperanto, their 1,000+ core RISC-V AI accelerator. That is, you know, the need for speed right there. Star5 has an AI visual processing platform. NVIDIA has been a huge fan and supporter of RISC-V since the beginning. And then you look at edge computing and the many ways in which high performance computing the promise and delivery that those massive calculations can bring to everyday computing, or otherwise, kind of help to shore up those new workloads, that's really where we're seeing things take off. Let me just leave it there, but those are some of my favorite examples of what we see going on, and these stories are coming out every day.
Absolutely. Thank you so much, Calista. I'm sure that, with so much literally happening around, I'm sure that the world has really so much to be excited about. So thank you again, Calista. Shiva, I have the same question for you. That what are our current ongoing plans when we talk about RISC-V?
Yeah, we are doing many things in RISC-V space. We have included RISC-V as part of our curriculum. So it's common for everyone, engineers, the new college graduates, corporates. So the beauty is actually every corporate engineer will also go through RISC-V as a case study. So as I mentioned, right, we walk them through processor design as part of our foundation course. For example, you look at how we train new college graduates. They come to Maven Silicon because they want to see themselves as chip designers. So what I do is actually I take them through processor design, and then I find out whether they are good for design or verification or DFT or physical design. So it's my responsibility to identify their strengths. If someone is good at logic design, yes, obviously they would be good for RTL design. But when it comes to verification, they need to have programming expertise. It's entirely different. So based on RISC-V, I classify them, whether they are good for design, whether they are good for verification, or whether they can deal with something else like design for test or physical design. Right? See, that's the beauty. And we train more than 1,000 engineers every year. So the beauty is every engineer will go through RISC-V processor design. And also, we included a RISC-V as part of our corporate courses. From Jan 2022, I would say like we train more than 200 engineers for one customer. I'm not talking about 10 customers. For one global MNC, we train more than 200 engineers just from January. Right? So that's a big achievement. And we recently started with a RISC-V master learning program. We introduced this to one of our global customers. Currently, more than 50 engineers, they are taking up our courses, and they are looking at different aspects also, RISC-V design and RISC-V verification. If I look at new college graduates, I would say like till now, we train more than 1,000 engineers. We also offer internships for the engineers who want to learn only processor design. So that is something called a RISC-V internship. So these are all some of the things I love to share with Calista and then with you, sweetie. Good. Yeah.
Great. So thank you so much, Shiva, and that definitely sounds like a plan. So on the same lines, Calista, what does the future hold for us when we talk about RISC-V? If there's any inside information that you'd like to share with all of us.
We are absolutely honored and humbled to see so much growth across the compute spectrum. I think the difference between RISC-V, in addition to the amazing technical freedom and design freedom that you have, the explosion in opportunity, is that, RISC-V really fits across many different types of implementations. So, considering that and having the knowledge to be able to bring to your teams, to your development partners, to your management, to everyone around you, having the knowledge to be able to understand how that microprocessor design could be realized differently or better with RISC-V helps you make great strategic, long-term, durable choices. We don't have the luxury of software design where you can change your mind, you can issue a patch. We need to get as close to perfection as possible before you go into production, before before you go to the fab. And that's something that, we are doing together as a community. By keeping everything open, you can design together with your other stakeholders, with your supply chain, with your development partners, and do so in a community, in a forum that still allows you to be wildly competitive and successful, as we've seen with Andes, as we've seen with Sci5, as we've seen with Maven Silicon, that allows you to really kind of bring things to the next level. Being successful in microprocessors or in any business is not about making small incremental improvements. That's not going to get you very far, very fast. Making leaps forward is how you're going to be competitive and how you're going to realize the incredible promise that you have with RISC-V. So, the things that we're doing and that we're seeing in RISC-V that point to a very bright future is the incredible growth that we're seeing in our community. I mean, we grew last year 132%. We grew the year before 131%. I mean, these are amazing growth. Like, most people like to grow 3 to 5% a year. Like, we are multiplying ourselves in our community. We have, around 12,000 developers that are engaged in RISC-V today. We have more than 2,700 members. You need to engage in that community. You need to be part of that community. We have more than 60 different technical work groups going on right now. That is an amazing complement to the education and knowledge that you get from organizations like Maven Silicon, right? Take that learning and go work shoulder to shoulder with your peers in the industry. Go work side by side in these communities to really kind of foster your own knowledge, continuous learning of your own, as well as to build your network. Because the stronger your network and the stronger those relationships grow, the more strategic for you personally in your career and the more strategic for your organization. So, my hat tip and my gratitude to Maven Silicon for the amazing level of training that you're providing. I mean, 200 engineers, that's incredible. And by doing that, you are fostering that success, that opportunity for those engineers to make smart choices for their careers as well as for their organization.
Great. Thank you so much, Calista. That was really, really kind. And Shiva, would you like to add to that? That what are our plans with respect to RISC-V when we talk about any upgrades in the curriculum or the way that we've been doing things until now? So yeah.
Yeah. So before getting into our plans, how I visualize the future of RISC-V, engineer's perspective, it's different. See, what we are looking for is something like new things will happen, new applications will demand new kinds of processors. Of course, there will be new threats, security challenges. And if you look at how things are going on, right, we started off with RV32i, RISC-V 32i, and then later on 64 became popular, but nobody knew that whether someone would be using 64 extensively, right? But today we are using it. So definitely in future, RV128, RISC-V 128 bits will also be used. We would be using that extensively for different kinds of applications. But the most important thing for us, for engineers, we are looking at something like industry standard ISA. That's what's going to happen. So RISC-V will emerge as open industry standard ISA. No more proprietary ISAs. This happened in our industry also. In my career, actually, I have been dealing with proprietary languages, IEEE standard languages also when it comes to verification. Today, if you look at System Verilog has become so popular, everyone is talking about System Verilog. Even people like Calista also might be comfortable with System Verilog, the term. Why it has become so popular? Because it has become IEEE standard. People love to play with standards, right? Not proprietary stuff. So I think moving forward, we don't want to deal with too many proprietary ISAs. Currently, if you look at different companies, different organizations may have proprietary ISAs for specialized processors. So that's where RISC-V is going to emerge as industry standard ISA, and there will be one ISA, and then people will create their own extensions if they want to customize the processor, or they can even customize the base ISA also as they prefer, right? So that's going to be the future. When it comes to Maven Silicon, we want to upgrade our courses. There have been so much demand for RISC-V based courses. We need to add some more topics. For example, RISC-V processor design, we want to introduce topics like complex pipelining and low power mode. We want to explain more about compilers, debuggers. So there could be many more topics. That's how the course is going to evolve. Also, we are looking at creating master programs like designing system on a chip using RISC-V. How about that? So we want to provide something like a course for 1 year, course for 2 years, rather than looking at short-term courses. Only for RISC-V. So they will learn the basics. They can learn how to use all the fundamental blocks to create RISC-V processor. And then they will be working on all aspects of RISC-V, complex pipelining or low power mode implementation. It could be anything. And then using RISC-V processor, how they can build any kind of SoC, system on a chip. For that, they need to understand everything about SoC, how basically we use different kinds of IPs along with processor. So they need to be familiar with some of the protocols like SPI, UART, and how we build the bus fabric. Which one would be the right option? Can we go with AMBA? Then there would be different flavors like AXI, AHB. Then how to design different kinds of bridges. Then how to put all the things together. Of course, they need to understand other things also, like pin multiplexing, and then general purpose IOs. There will be system controller, how basically we generate clock. They need to understand analog components also. But if they can create even a simple microcontroller, that would be great, embedded systems controller. And that's going to be based on RISC-V processors. That's how our course is going to evolve. That's what I wanted to share with even Calista also.
Wow. I think that's a very, very massive and elaborate plan, I would say, Shiva. And Shiva, thank you so much for that. Moving to the next question very quickly. Calista, this question is based and on behalf of all the VLSI aspirants that we have around, and it'll be really kind of you and nice of you if you could just share a few tips if somebody wants to have and build a long-term career in the VLSI space. What are a few tips that you would like to share with them? And probably then Shiva.
So I think my two biggest tips would be to go broad and to go deep. Become a deep expert in an area that is important to you, and then go broad. Understand how your piece of the puzzle fits within the entire ecosystem of stakeholders around you. So, there are many parts of this ecosystem. You have the software stack, from boot, hypervisor, operating systems, runtimes, and other applications. How does your piece of the puzzle interact with the software stack? How does it interact with pieces of debug and security and performance? What is your influence there? What about reliability and serviceability and diagnostics, things of this nature that are very essential as well? How does your piece interact with design verification or RTL or implementation, and how those pieces come together? What about testing or other profiles and analysis and simulators and compilers? How do you interact with each of those other pieces so that when you propose or move forward on a design, that it interacts well within the rest of the community and can help you make those leaps forward. And then think about how you give back, how you bring others with you. So think about, do you have a strong mentor in your domain? Are you mentoring others? Do you have colleagues, peers? Build those networks. As I mentioned, go work shoulder to shoulder with others in your domain. Go pick one of those 60 work groups that we have. Join RISC-V, of course, but go work shoulder to shoulder with one of those other one of those other work groups, or just be a spectator. Listen in. What are the hot topics going on in each of these various areas? We have domain experts across the field, right? And when you work together, you learn faster and you understand better and more deeply what the influences can be. So those would be some of my tips on kind of pursuing a career in this particular space.
And I would say that very, very well put, Calista. I have myself taken a note of it. Broad and deep is something that I'm going to probably remember forever. So thank you so much for that. Shiva, the same question for you, that, what are the few tips that you would like to share with our young engineers?
What I would say, ask yourself, is VLSI your cup of coffee? I'm talking about only VLSI, chip design. Don't come to Maven Silicon just for the sake of getting job. I want to be transparent with you. And I love to work with engineers who are truly passionate about VLSI. If you are not going to be my type, my boy, then it would be difficult for me to connect with you, right? That's the most important thing. Also, don't assume things like only VLSI is the greatest thing in the world. You can deal with IT support, you can deal with embedded systems, you can deal with software programming. Everything is good, everything is needed for us. So you should not choose your domain based on something like popularity. Oh, this technology is so popular, this is fancy. Also, be open-minded when it comes to doing your job. There may be challenges for organizations, there may be challenges for mentors. If I look back how I started my career, right? Initially, I was doing EDA installation. That was my first assignment. So I was working like IT support guy. It was kind of frustration because I had to deal with EDA, electronic design automation tools installation. But I didn't know what's going to happen to me in my life. I didn't know the destiny. So that experience was highly needed when I wanted to found Maven Silicon. Because that time, nobody was there with me. I just came out of the industry and then I founded Maven Silicon, registered my company as private limited company. I was there for everything. I was the salesperson, I was the engineer, and I was the trainer. Right, I had to do everything, and I was the IT support guy. So I bought EDA tools from one of the EDA companies, and then I installed EDA tools on my own. Right, I knew about everything, what was going on in my facility. Right, so sometimes when things don't happen to you, don't lose your motivation. Whatever you do, do it sincerely. That's going to pay you back. At the same time, don't give up your dream. You are there to share your concerns with people. Be open-minded, discuss with people. You can always negotiate with people. That's how I negotiated with my first employer. And then my boss helped me to move to EDA. So they had a dedicated team for the EDA support. That's how I became application engineer. And that's how I got into the EDA industry. Right. So later on, I got a job in Cadence. There I explored different kinds of things like verification methodologies or languages. And then I quit my job, then worked in Synopsys. But how everything happened, because I negotiated with my first employer, I asked them also, like, what I'm doing probably might not help for my future. So can you help me to explore something else? Right? So talk to people. They are there to help you. That's what really important. And the most important thing is you have to be curious. Learning is a continuous process. Don't be happy with what you know. You are there to ask yourself also why. Why is the big question? How this is happening? So that's what I ask myself also. What is smartphone? What is laptop? What is CISC? What is RISC? That's how you need to ask. And I use Google extensively. I Google for everything. I use Wikipedia. Wikipedia is a good reference, right? This is the kind of thing that will help you to build your long-term career, right? You have to be really skilled. At the same time, your attitude is more important. You have to be flexible. You have to be open-minded. You should always feel like I'm part of the community. And if you are going to learn anything good, what is expected from you is one day you will be sharing your knowledge with the community. That's what Calista also mentioned, right? And there are amazing forums like RISC-V International. Be part of such non-profit organizations. They are there primarily for the community. And that's highly important for engineers community. All right.
Yeah, great. Thank you so much, Shiva. I always hear it from you, and you always say that, know the why behind everything. And this is something that I have learned to grow up with probably for the last 3 years. And I think everybody should begin their journey with that, knowing the why behind everything. So thank you so much for that. I know the clock is ticking, and I think I'll just come to the next question and perhaps the last question for today's discussion, and that's for both of you. Both of you are the CEOs of very popular, if I may say so, and very loved organizations, right? And of course, technology-wise, process-wise, both the organizations are doing brilliantly well. I would really like to understand that what is your take on the organization culture? We talk about inclusivity, sensitivity, gender awareness, professionalism. We talk about women in business, right? What is your take? So I think probably Calista, I'll begin that with you.
So I think it is important to do two things. First, for women to step forward and find their power, find your voice, but also for employers and organizations to recognize and create space, create opportunities to cultivate women in their careers, whether they are starting their careers, in the middle of their careers, or becoming leaders in their communities and leaders in their organizations. It is on all of us to drive ourselves as women. It is on all of us to create opportunities to cultivate the success of women around us. Now, let me just take it from the as a woman perspective. What should you be thinking about? First of all, it's not easy to always step forward into the spotlight, because the spotlight it's also the heat lamp, right? It is also, can be very blinding and very reveal everything, right? But it is important to take those steps. So find, as Siva put it, find something, that piece that you are really passionate about, because that passion is going to drive you. That passion for your expertise, your area, is going to compel your career. And others are going to want to be with you, right? You're going to want to be around people who are also equally passionate about your career. If you're not passionate about EDA design tools, then go do something else, right? There is room for many different areas to become an expert. The second thing would be, choose a company or an organization that you believe in, right? I was an entrepreneur before I joined IBM, and I was very passionate about IBM, the purpose, their culture, right? I was very passionate about the company. And I joined, I was like, well, I'm going to join IBM and I'm going to grow my career there. And now I'm very passionate, and I've cultivated a passion in my career for leveling the playing field through open source, to create opportunities for everyone in hardware, taking hardware to be open as software has become. And that is a driving passion for me. And so I get to get up and go to work every day for a company I believe in. Find that company you believe in and figure out how to join them and grow with them. I would also encourage you to look for roles, look for positions and opportunities that have high visibility. If you're simply, running tasks in, a dark corner, you're not going to grow your career very fast. Become visible. Figure out ways to connect with colleagues in the community, connect through social media or other areas. And I would say to the company side, foster the strength of the individual first, the company second, right? Put yourself in the back seat. Put your company in the back seat. Help to foster the success and the leadership and the eminence of the individual, of the female who is early in their career, mid-career, leadership in their career. Foster their success as a human being. And then maybe you can say, and by the way, they work for, XYZ company. That's great. But really, it's about their success. Because at the end of the day, humans are successful because they feel valued. If my company and organization values me to put my name first, that speaks a lot to the credibility of the company and how much they value me and my contribution. So then I would also encourage you, go the extra mile or kilometer. Go the extra length and stretch yourself to not just complete the job, but do it in a way that is strong and durable for the test of time. Don't just cross things off the list. Make your best effort because it shows, it shines through. You are going to be the person who others look to help solve things. And by the way, next tip, solve problems that matter. When you find a problem, don't just pass it on to somebody else. Stay involved with it, engage in it, solve it, because you're not the only one facing it. And you solve it today and everyone benefits, that's going to come back and reflect on you. Along the way, build a deep network. Build a deep network of folks who are earlier in their career than you, who are your peers and colleagues, who are your role models and leaders. Find folks to build your career with and build those relationships in meaningful ways. Don't just connect with them on LinkedIn and say, hey, I want to connect with you. You look like somebody that I could connect with. Build a relationship. Figure out how you can contribute to their success and they can contribute to your success. Along the way, start to cultivate your leadership. Lead a project. Lead a, team initiative. Pretty soon, folks will start to see, that's a leader I can count on. I'm going to give them more responsibility. I'm going to open an opportunity. When I have an opportunity to grow a particular area of the business, I'm going to think of them for that position and that role, because that network and that leadership progression is what helps build your career. And then finally, lift everyone up. Lift up the people around you. Shine the light on others around you. Don't just keep that light for yourself. Shine it on others around you to help cultivate their success. People remember who recognized them and who helped them move forward in their career. So you can do that for others, even as you continue building your own career. So I have that, that's my advice as women, as folks early in your career, and as companies. Think about how you cultivate those types of environments that bring success to everyone. As leaders, put other people first. Don't put yourself out there, because it's not about waving your flag. It's about lifting everyone and bringing the entire group forward. So those would be my thoughts.
So thank you so much for that. And this was actually a brief TED talk for me, if I may say so, Calista. So thank you so much. Really, really inspiring, I would say. And Shiva, coming to you, I will tweak my question a little bit over here. I've been working with you for 3 years now. And when I see Maven Silicon, I see people welfare, right? So Maven Silicon has always been this organization which has been so driven for people, right? And we've been growing leaps and bounces right now. But ultimately, everything boils down to people. Everything boils down to the employees at Maven Silicon. So how do you do it? How do you just strike this balance between business and people? And how do you do that? More than 70% of our workforce is women. Uh, how do you take care of everyone so beautifully?
Good. You rightly mentioned more than 70%. I would say 60% are women at Maven. In my experience at Maven, I think women do much better than men in some areas. So they are very confident and highly creative. My co-founder, Pravina, she's kind of composed and honest, and she's very detail-oriented person. But I always look at big picture. I'm a creative person, and I always think like how to do things differently at Maven Silicon. But in parallel, she always looks at all the details, right? That kind of combination is highly required. So even if you look at the board also, there is a female. She's board of director, and then she's part of everything, like how we can redefine the process, how we can take care of the employees. That's why you are all doing great, and you're all super talented women. It's very challenging every time when I think of a particular assignment, right? I have to really think about it also. Who is going to do what and how this is going to excite my employees. That's important. See, basically, organization's culture reflects the style of leadership. So my style is actually doing everything creatively. We want to be different. We want to be unique. So to do things differently, we need smart people. So my biggest responsibility is doing all these kinds of events and communicating to the world that we are a good company, and then please come forward to work with us. So it's my responsibility to attract smart people like Calista, smart people like Sweetie, everyone. Right? That's where organization's culture is very important, because smart people, they are very choosy. They look at like, is there any transparency? What about your business ethics? How you take care of your employees? What about their freedom? Freedom of expression is more important. Calista rightly mentioned, right? Allow people to grow. They need to have their own space, and people should also be truly passionate about their career beyond company. That's how I would like to choose people. Think about your career. If you are very passionate about your career, long-term career, obviously you will do all great things for your company. So to work with smart people, we really need to be sensitive to our organization's culture. Our culture is pretty much based on our core values, how we want to take care of our customers, how we want to do business, our business ethics. When it comes to customers, right, we don't differentiate customers like whether they are corporate customers, new college graduates. For me, everyone is same. I respect everyone. That itself is a big thing, right? Because I have been watching this space, VLSI training space. Generally, we don't prioritize training college graduates. Oh, it's okay. It's kind of charity work. But it's your choice, right? You really want to uplift them. Then you have to connect yourself with these college graduates. You have to do something good for them. So organization's culture is very important. What I believe in is lead without title. I'm here to give you different designations, promotions, whatever you want, fine, but lead without title. That's what I would like to share with you. All right.
Great. Thank you. Thank you so much, Shiva. And I've always seen all of that you've been saying. I've always seen getting reflected in our day-to-day operations and activities. And yes, that's it. I think we call it a wrap here. And thank you so much, Calista, Shiva, for both of you and for your time today. And Calista, it was lovely meeting you, honestly. I'd always, love to stay connected. Thank you so much for your time. Thank you.
Really appreciate the time together, and it's great to connect with you. Thank you so much.
Thank you so much, and thank you so much, Shiva, as well. And as you said, let's keep doing more of such chat sessions with all our industry partners around. And yeah, thank you so much. If you have any words here.
Thanks, Viti. Thanks, Calista.
Great. And for our audience watching out there, thank you so much. This was episode 1 of Experts Talk. Please stay tuned, and we are going to come back, with more such interesting conversational chat sessions. And thank you so much, everybody. Take care. Thank you.